logarithms. A common logarithm is a number that you have to raise 10 to that power to get whatever you're taking the logarithm of. So we call this the common logarithm function because our base here is 10. Now what's special about 10? 10 is the number that our entire number system is based on. Okay. So if we're trying to find the log of x, that answer is going to be whatever power you raise 10 to get the x. So if we evaluate these logarithms, the log of 10 to the 5th power, we're looking for whatever power we raise 10 to get 10 to the 5th power. Well here, that's pretty simple because it's already written as 10 to the 5th power. So our answer here would be 5. On this next one, the log of 1 over 1,000, we need to be able to write that as the log of 10 to a power. And this power will be our answer. So if we think about 1 over 1,000, what we know is 1,000 is 10 to the 3rd power. So if we have 1 over 10 to the 3rd power, that's the same as 10 to the negative 3rd power. So the log of 1 over 1,000 is the log of 10 to the negative 3rd power. So our answer would be negative 3. Now sometimes we'll have a base other than 10. Our base will always be a positive number, but we're still looking for whatever power we have to raise that base to give us our x. We call this the logarithm function with base a. So here we want to try to write these numbers using powers. So if we have the log base 3 of 81, we want to write that as the log base 3 of 3 to some power. And that power will be our answer. So if we think about 81, and we can try different things on our calculator, to raise 3 to the 2nd power, 3 to the 3rd power, we find that 81 is 3 to the 4th power. So the log base 3 of 81 is the same as the log base 3 of 3 to the 4th power. So our answer here would be 4. Log base 2 of 1/8, we want to do the same thing. We want to write the 1/8 as 2 to a power. What I know about 8 is 2 cubed. And since the 2 cubed is in the denominator, I can write it as 2 to the negative 3rd power. So this expression is the log base 2 of 2 to the negative 3rd power. So my answer here would be negative 3. Now this logarithm looks different because it's ln instead of log. The ln is the same as having a log with a base of e. So if we have a log with a base of e to the 8th power, our answer will just be the 8. When we have logarithms, our domain, this part right here, has to be positive. Okay. We can't take the logarithm of anything that is not greater than 0. So to find the domain, we're going to set whatever we're taking the logarithm of, in this case it's 3x plus 1, we want to set it not equal to 0, but greater than 0. Let me erase here so that'll look a little neater. Three x plus 1 is greater than 0. So I solve that. I'll subtract the 1 from both sides and divide by 3. So x has to be greater than negative 1/3. In interval notation, it would start at negative 1/3 and go up to infinity. Now here, this expression looks very similar to what we were just looking at. Our base here is the same as the base here. So to find that logarithm, these bases would cancel out, and our answer would just be 8 x squared. But this one is just written in a little bit different form. Instead of the log with a base, it's actually got the base to a power, and within that power, you have the log base 4. So when you have that, these cancel out, just kind of like these cancel out. So your answer here would just be the x minus 8.